Hey everybody, we need to talk about the periodic table today, and specifically the families in the periodic table. So you should have your 3.0 notes page in front of you, and you'll be filling this out as we go. So let's jump in. Let me make my face a little bit smaller here. All right, so a little bit about the history of the periodic table. There was this dude named Dmitry Mendeleev. He was a Russian scientist who came up with our modern periodic table. There were a lot of different ways that people had organized the elements throughout time. Lots of different ways people organize the periodic table over time, organized by different characteristics of the elements and things like that. But Dmitry Mendeleev, like I said, came up with the modern periodic table the way we see it today, the way it is here on my board in the classroom. I'm not going to play this video here within the video, but if you want to take a little break and head over to YouTube and watch this, if you search Crash Course Chemistry number 4, it would probably pop up. You don't have to watch it in order to complete these notes, but there's interesting stuff in there. So if you're interested in chemistry, if you're interested in history, there's some interesting stuff that you might enjoy learning about. All right, here's what you do need to know. You do need to know that we call the side-to-side horizontal rows in the periodic table periods, okay? Think about it like if you're looking at a calendar and there's weeks laid out on the calendar. That's the same thing. It's like periods in the periodic table look like weeks in a calendar. So one question I like to ask students is how many periods are in the periodic table? Well, we've got 1, 2, 3, 4, 5, 6, and 7. So then students like to say, well, what about these ones down here? Is it 8 and 9? No, because look, the colors match up, right? This pink color matches with this pink color, and this teal matches with that teal. And actually, this whole chunk down below actually fits into this little gap right here. We'll talk more about that when we talk about the different families in the periodic table, but keep that in mind. Now, the next one is groups. The vertical columns, they go up and down. Now, I don't know, there's 18 groups in the periodic table. You'll see in this diagram that the middle ones aren't colored in, but we still would consider these groups. This picture is showing something a little bit different, but I just wanted it to show that vertical grouping. But again, there are 18 total groups in the periodic table. My periodic table up here is actually labeled, so you could look at this one in the classroom to see that there are 18 up there. Now, what makes an element behave the way it does? So a really important part of understanding how elements are going to behave is knowing how many valence electrons they have. Valence electrons is something we talked briefly about before when you guys were doing your element research project. To summarize, valence electrons are the electrons in the outermost energy level of an atom. So let's look at an example atom. Let's back up actually a little bit and review. Hopefully you remember that the protons and neutrons in an atom go in the middle in the thing called the nucleus, and then the electrons are outside of the nucleus. Hopefully you remember talking about that. So here we can see we have 8 protons and 8 neutrons, and if we count all the electrons, we have 1, 2, 3, 4, 5, 6, 7, 8, which is good. That's what oxygen is supposed to have. But its total number of electrons is different from its valence electron number. Remember, valence electrons are only the electrons in the outermost energy level, so I'm actually going to ignore these two in here. All I care about when I'm thinking about valence electrons is this outer shell. So if we count those, we have 1, 2, 3, 4, 5, 6 valence electrons in this atom of oxygen. Let's look at another one. Here's fluorine. So again, ignoring anything on the inside, ignoring these two, fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. A couple more examples. Potassium has a ton of electrons. Looks like it has 19 electrons in total, but only one of them is a valence electron, and it's this little guy right here is our only valence electron. Final example, magnesium only has 2 valence electrons, this one up here and this one on the side. All those other electrons are on inner shells and they don't really matter. A brief explanation of why this is important. Think about an onion. Just like if you've seen the movie Shrek, you know that just like ogres, onions have layers, right? So imagine you're holding an onion and you know it's got all those layers on the inside, but you're not touching any of those inside layers, right? You're only touching and interacting with that outside layer of onion. Well, atoms are the same way. They might have all of those inside layers of electrons, but only that outside layer is actually interacting with the world around it. And so that's what determines how the element behaves, is just what those electrons on the outside look like and what they are doing and how many of them are there. So that's why the outside valence electrons are the most important. One last thing about valence electrons before we move on, it's important for you guys to realize this, is that for much of the periodic table, you can know how many valence electrons an element has by looking at its group number. Now, I realize this table doesn't have group numbers shown above the table, but again, if you look at my one in the classroom, you'll see that there's a little 1 up here above the table, there's a little 2, there's little numbers all along here and along here to tell you what the group number is. So if I asked you how many valence electrons, what element is this? Calcium has. Calcium is right here on the periodic table. You would know if you're looking at this one or any other periodic table. All you would have to do is say, okay, calcium is right here. I'm just going to look at its group number. Oh, it has 2 valence electrons, okay? So often the group number will tell you the number of valence electrons. Now, over here on the other side of the table, you might notice it's a little bit different because actually this is group number 3, group number 4, group number 5. Over here, this is actually group number 13 and group number 14 and 15 and so on. Like I said, there were 18 groups total in the periodic table. So over here, it's easy. All you got to do is look at the group number. Over here, it's still pretty easy. All you have to do, though, is ignore the 1. So if I ask you, this element right here is aluminum. If I wanted to know how many valence electrons were in aluminum, all you would have to do is look and see that it's in group 13, and you'd say, oh, I'm just going to ignore the 1. It has 3 valence electrons. Okay, so that's a handy little trick for you to know. Couple of exceptions to that. Obviously, in the middle section, there's nothing labeled. That's because these middle elements, these are families that don't follow those specific rules. So I'll never ask you to know how many valence electrons are in any of these. So don't ever worry about that. If I ever ask you how many valence electrons something has, it will be in one of these groups that's numbered here on this periodic table right now. The other thing, some of you who are observant might have noticed that helium, sorry, I'm pointing over here, which is the opposite I'm seeing on my little face down here. Helium has only 2 valence electrons, even though it is in group 18. So the reason for that is that basically everything in this column has a full valence electron shell. The first shell only holds 2 electrons, and the next ones usually hold 8 electrons. So everything here has a full valence electron shell, which makes it behave a certain way. So a lot of students say, well, if it only has 2, why doesn't it belong over here? It's sort of complicated, but basically just know that helium is the only one that doesn't follow that rule. This is where it belongs. It does line up best. Its behavior lines up best with these other things in this group. Just know that it doesn't quite follow that rule the same way. All right, that's it for the top part of your notes. Come on back for the next part where we start talking about the families in the periodic table.